We're going to start our first unit by going over slopes and equations of lines. So we'll start off by talking about the slope of a line. Now the slope of a line is what we call the steepness of the line. And the way that we can define the slope of a line is to define it as the vertical change divided by the horizontal change. In terms of symbols, if you take 2 points on a line, x1, y1, and x2, y2, then the slope is going to be equal to y2 minus y1 over x2 minus x1. By subtracting y2 minus y1, you're finding the change vertically, and by finding x2 minus x1, you're finding the change horizontally. And then dividing those two will give you the slope. So as a picture here, we have a line, and if you have these 2 points, x1, y1, and x2, y2, then if you look and see, this is actually just the difference between y2 and y1, and this here is the difference between x2 and x1. And so subtracting those and dividing them will give you the slope. Let's take a look at example 1. Find the slope of the line through the following pair of points: 7, 6, negative 4, 5. So simply, we are going to find y2 minus y1 over x2 minus x1. Now it doesn't matter which point you make x1 and y1 versus x2, y2, as long as you stay consistent. So for example, I'm going to label 7, 6, x1, y1, and negative 4, 5, x2, y2. So now I'm going to have 5 minus 6 over negative 4 minus 7. So that comes out to be negative 1 in the numerator, negative 11 in the denominator, and that's equal to positive 1/11. Now let's talk about some specific cases in the slope of a line. So when you have a line with a slope of 0, that means you have a horizontal line. So if you take a horizontal line here, imagine you have x1, y1, and x2, y2, you'll notice that y2 and y1 are going to be the same. x2 and x1, on the other hand, are different, but it doesn't matter what they are, because it will still be 0 over x2 minus x1. 0. Now, there are certain lines that we say have no slope, and those are vertical lines. Here's a vertical line. Let's say this is x1, y1, this is x2, y2. Now you'll notice here that your x1 and x2 are the same, whereas your y2 and y1 are not. Now, regardless of what y2 and y1 are, if x2 and x1 are the same, that must mean that that denominator is equal to 0, which is why this slope is undefined. Or you can say there's no slope. Now, when we talk about equations of lines, this involves slope, and a lot of the times when we work from an equation of a line to graphing a line, we'll want to know what the slope of a line is. But there are different forms of the equation of a line. First is the one you're probably most familiar with, is slope-intercept form. This is the one that we use to find the equation of a line when you're given the slope and y-intercept. This is y equals mx plus b. The second is point-slope form, and this is the form that we use to find the equation of a line when you're given the slope and a point on the line. So in the first one is when you're given the slope and the y-intercept. Point-slope form, as the name suggests, is when you have the slope and you have a point on the line. So this is the y minus y1 equals m times x minus x1. Let's take a look at example 2. Find the equation of a line in slope-intercept form for a line that goes through 0, negative 3, with a slope of 3/4. So simply in this one, you are told the slope is 3/4. Now the point that it goes through is at 0, negative 3. Now because x is equal to 0, you actually know that this is the y-intercept that's given to you. So the y-intercept's at negative 3, the slope is 3/4, so we can actually use slope-intercept form and plug in for the slope and the y-intercept and get our line. So y equals 3/4 x minus 3. All right, the second part, we have using point-slope form, find the equation of a line that passes through the point 4, negative 7 and has a slope of 3/4. So in this case, we have a slope given to us and a point that's not the y-intercept that's given to us. So here we'll use point slope form, and we're going to plug in for the slope 3/4 for m, and then we are going to plug in for the point 4, -7 for x1, y1. All right, and then let's simplify this. So now we have y plus 7 equals 3/4 x minus 3. Get y by itself, so we will go ahead and subtract 7 from both sides. We have y equals 3/4 x minus 10. All right, let's talk a little bit more about equations of lines. So in addition to those different forms that we just went over, we can also talk about very specific cases of equations of lines. So when you have horizontal lines, the equation will be y equals some value of k, where k is the y value that the line goes through. For vertical lines, you'll have an equation of the form x equals k, where k is the x value that the line goes through. Now with parallel lines, we know that two lines are parallel if and only if they have the same slope, or if they are both vertical or both horizontal. So in the case where you may have a slope of 0, if both lines have a slope of 0, you know they're parallel. If both lines have an undefined slope, then you know they're parallel as well. Perpendicular lines are lines where the product of the two slopes is equal to -1. So if you have the equation of two lines to check if they're perpendicular, all you have to do is multiply their slopes together. If they're equal to -1, then you know they're perpendicular. Another way to think of this is that they are opposite reciprocals of one another. So opposite meaning if one's positive, then the other's negative. Reciprocals meaning that the fraction is flipped. The other case is if you have a line that has 0 slope, then the perpendicular line is going to have an undefined slope and vice versa. All right, look at example 3. Find the equation of the line passing through the point 3, 7, and parallel to the line having the equation 5x minus y equals 4. Now, in order to determine what the slope of the equation is, we need to know what the slope of this line given to us is, because it's parallel to it. So let's start with the line given to us, and let's determine what the slope is. So I'm going to move some things around until I get it into slope-intercept form. So this is equal to y equals 5x minus 4, and now it's very clear to us that the slope is 5. Now that we know that the slope is 5, we can use the additional information of this line passing through the point 3, 7 to find the equation. So now we're going to use point slope form. Y minus 7 equals 5 times x minus 3. And we'll go ahead and simplify this as much as we can. So this is y minus 7 equals 5x minus 15. Add the 7 over, we have y equals 5x minus 8. And that is the equation of the line that will go through the point 3, 7 and is also parallel to that equation 5x minus y equals 4. All right, take a look at example 4. Find the equation of the line passing through the point 3, -6 and perpendicular to the line having the equation x equals 7. Now x equals 7 is a vertical line, which means that if we're trying to find the equation of the line perpendicular to it, it must be a horizontal line. Now remember that with horizontal lines, the equation of that line is going to be of the form y equals k, where k is equal to the y value. In this case, we know it goes through the point 3, -6, so our y value must be -6. So the equation of the line is going to be y equals -6, and that is a horizontal line going through the point 3, -6. Let's talk about graphing lines. So to graph a line, we will need any 2 points on that line. So there are many ways to find 2 points on that line, including, here are going to be a couple of different ways to do it. finding two ordered pairs that satisfy the equation by plugging in values of x to find values of y. That's one way to do it. Just plug in a value of x, get a value of y, do it again. And once you have two of them, you can draw a line. Another way to do it is to find the x and y intercepts by setting y equal to 0 and x equal to 0. That's a pretty easy way to find two ordered pairs, is simply by saying, okay, when x equals 0, what is y equal to? When y equals 0, what is x equal to? And that will easily give you 2 points. The last way is probably the way that you're most used to graphing lines, which is to find the y-intercept, graph that point, and then use the slope to find a second point. So this next example, I'm going to show how we can use all three methods and get the same line. So 3x plus 2y equals 12. So in the first method, you find 2 points. So for example, you take x equals 0, and you plug 0 in, and you solve for y. So we have 0 plus 2y equals 12. Divide by 2, we get y equals 6. So we have a point at 0, 6. Now let's plug in another point. Let's say x equals 1. So we have 3 times 1 plus 2y equals 12. So we have 2y equals 9. So y is equal to 4.5. So now we have 2 points that we can graph at 0, 6 and 1, 4.5. And if we draw our line through those 2 points, that is the graph of our line. So as long as you have 2 points, you'll be able to graph your line. Now I'm going to go through the other 2 methods just so you can see how we come up with the same line. So in the second method, you find the x and y intercepts, which means you set x equal to 0, find what y is, which we actually already did. You can set y equal to 0, and that gives us 3x plus 2 times 0 equals 12, so 3x equals 12, so x equals 4. So this gives you the x and y intercepts where this line crosses x and y, and 0, 6, which is actually already one of those points, and then 4, 0 is another point. So if you had just those 2 points, you'd also be able to graph this line. The last method is the one you're probably most used to doing. Now, in some cases, this is easier, but in some cases, probably in this case, it's actually a little bit more complex because you may need to move a lot of things around until you can actually get the slope and the y-intercept. So here, to get it into slope-intercept form, we have to subtract 3x, divide by 2. So now we have negative 3 halves x plus 6. And now we're going to graph our y-intercept, which is at 6. And then you would go down 3 and over to the right 2, which would lead you here to this point at 2, 3. And you'd be able to draw that same line. So all 3 methods are fine, but notice that the common thread in all 3 methods is that we were finding 2 points in order to draw our line through it. Now let's go the other way. What if you're given the graph of the line and you have to come up with the equation? Alright, so here is the graph of a line, and we want to come up with the equation. So in this case, it might be pretty easy to use slope-intercept form and plug in for m and b. So to start us off, we can easily see where the y-intercept is, which is at negative 5, so I can plug that in. And now I just need the slope. Now I can start at that point at the x-intercept there, at negative 4, 0, and count. Remember, it's rise over run, so I'm going to count down first. So it looks like we go down 1, 2, 3, 4, 5, and then we move to the right 1, 2, 3, 4. So our slope is negative 5 over 4. And that is the equation of our line.